So we're going to define a new function called hx, in which we're going to add the expressions of fx and gx together. We're going to simplify it by adding like terms. So x squared plus 6x, which is 2x plus 4x, 3 plus 6 is 9. Another function jx, we're going to subtract the expressions of fx and gx. And this is pretty much the exact same method, except just make sure to expand the negative sign because the whole bracket is multiplied by -1. We're going to simplify it again by subtracting like terms. So the superposition principle states that for all the points in DH, the sum or difference of two or more functions can be found by adding or subtracting the y-coordinates of the function at each x-coordinate. So let's take back the two functions that we had earlier. So the first was fx and the second one was gx. And we made a new function called hx in which we added these two functions together to form a new function. So if we were to use the superposition principle to make a graph of this or find the points of this, we can basically say that for each x value in this new function, the y value is the addition of the y values of fx and gx. So basically, if you had the new point, so this would give you one x or y, or in that case x and f of x. And this one would give you another coordinate for whatever x value you plugged in. And that would give you x and g of x. Oops. Okay. In terms of h of x, what coordinate would it give you? So it would have an x value, but it only has one y value for each x value that it has because it's a function. So the new y value is the addition of these two y's together, because this function is the addition of these two functions. So in other words, it would be this one plus this one. So the new coordinates are fx plus gx. And that's basically what the superposition principle states. Okay, so we're going to graph this. So this is fx. The blue line is gx, and when we put them together, it gives us the green function, which is hx. So as for multiplication and division, you do it in the exact same way. Just make sure for multiplication to expand your brackets properly using the FOIL method. So I'm just going to talk about a couple things to keep in mind when you're combining functions. So it's the domain, the zeros, vertical and horizontal asymptotes, and holes. So for domain, you're trying to find the domain of the new function. And it would be the domain of the two functions and where the domains intersect. However, if you get a rational function, because here in this equation, we're dividing. So you also have to make sure you know any restrictions. So let's do this. Domain of function f intersecting with the domain of function g. So if we look up here, f and g, their domains are as follows. So df and dg. So we can easily see that these ones are all real numbers. However, in the denominator, we can easily see that x cannot be -6/4 or basically -3/2. So the new function, the domain would be k, domain of k, and it would be up to -3/2, not inclusive, it's exclusive, union -3/2, infinity. The zeros are when the numerator is 0, and you'll see that if you plug this part into a calculator, the quadratic formula will actually give you undefined. So there's no zeros. It doesn't touch the x-axis at all. As for vertical or horizontal asymptotes, As for vertical or horizontal asymptotes, the vertical asymptote is when the denominator is 0. So as we said before, it's when x is negative 6 over 4. So the vertical asymptote would be at x equals negative 3 over 2. That's the equation of the line. For horizontal asymptote, there really isn't one, but the issue is this function is one that we haven't covered in the advanced functions course, so I'm not going to go over that right now, but check the end of the video because we are the AP class. I did some research online so I could sort of show you where the other asymptote will look like. And as for wholes, does anything in the numerator and denominator cancel out? So we don't see anything that cancels out here, well, this isn't factorable in the first place, so nothing really cancels out. So we're gonna say that there's no holes. And this, see end of video. Okay, so our good old friend Tuxedo Mask has a small business selling bow ties. So he has to pay $35 a day to rent his space in the mall, and it costs him $5 to make each bow tie. He sells each bow tie for $8, and he makes a maximum of 50 bow ties each day. So the first part says to write an equation to model Tuxedo Mask's total cost, defined as C, and revenue, defined as R per day, as a function of N, which is the number of bow ties sold. So if we look back into the question, let's do C first, and we're going to call this CN. So if he has to pay $35 a day, so that's a flat rate. And he has to make bow ties, and each bow tie costs him $5. So these two values contribute to the cost function. So since this is a flat rate, there's no variable. It doesn't depend on how many bow ties he makes. So that's just there. And depending on how many bow ties he makes, his cost can vary. So because the $5 depends on each bow tie, N, the variable, has to be stuck to 5 in the equation. For the revenue function, Rn, there's no flat rate. Well, there is, it's 0. So he sells each one for $8. So that means if he doesn't sell any bow ties, he doesn't get any money for it. But let's assume that he has good luck that day, and he does. So 8 times N would be how much revenue he makes each day. However, this isn't it, because if you look at the last part of the question, it says he makes a maximum of 50 bow ties each day. That means he can't make 51 bow ties. He's gonna be way too tired. So we have to put a restriction on the variables. So N, which is the number of bow ties, cannot be more than 50. But at the same time, it can't be less than 0 because you can't make negative bow ties. So the restriction would be that N must be greater than 0, and it must be less than or equal to 50. Because he can't make 50 bow ties, he can't make 51, but he can make 50. Same thing with the revenue function. We could technically also make this greater than or equal to, because he can technically not make any bow ties. So this would be your function. The next question says define a new function P of N that defines Tuxedo Mask's profit per day. So thinking back to grade 11 functions, profit is equal to the revenue minus the cost. So this is basically the net amount of money that Tuxedo gets every day based on how many bow ties that he sells. But you also have to take into account how much he needs to give to make each bow tie. So that's what profit is. It's how much you get after you take into account all the costs. So we have a function for cost that we made earlier, C of n. And we had a function that we had for revenue, which was R of n. And we subtract them, which gives us the new function of Pn. So this is basically subtracting two functions, as we talked about earlier. So what we're going to do is we're going to transfer these two functions down here to simplify it to P of n. P of n is R of n, which is 8n, minus, bracket, don't forget the bracket, 35 plus 5n. So we're going to expand this, which gives us minus 35 minus 5n. And subtracting like terms, which is these two, gives us 3n minus 35. So we can say that Pn equals 3n minus 35. However, we also have to remember what we said earlier, that n cannot be more than 50. So this restriction stays in here. So 0 is less than or equal to n, which is less than or equal to 50. So if you graph these functions, you can see something similar to what I have here. The red one is the cost function, the blue one is the revenue function, and the green one is the combined profit function. And if you see, the x-intercept is 11.67, which means if Tuxedo Mask makes about 11.67, so we can say 11 bow ties, or 12, that's when the revenue and the cost are equal, which gives a profit of $0. So basically what that means is that that's the break-even point. That's when revenue is equal to cost. So he doesn't make any extra money that day. So he sells just enough to make up for how much he has to pay, including rent and how much he needs to make each bow tie. So earlier in the video I was talking about how to find horizontal and vertical asymptotes. And those are easy for functions that we talked about or we learned in class for chapter 3, which was about rational functions. But those functions that we're familiar to are quite different from this one. The reason is this numerator has a higher degree function than the denominator. In previous classes, we've only talked about those that are either the same or the denominator is less. Because this is quadratic, so it's 2 versus 1. In that case, you don't get a perfect horizontal asymptote. You get something that's sort of, you have a vertical asymptote, but you have a slanted horizontal asymptote, if you get what I mean. And this is what an oblique asymptote is. So I'm just going to show you how you're going to find the equation of the line. And basically, it's actually really easy. Basically, what you're going to do is you're going to divide the numerator by the denominator, and using long division, which is something that we've learned before. Woo! Okay, what is even going on anymore? So we're going to divide the numerator by the denominator. So 4x plus 6, 8. You're just going to So when you divide the numerator by the denominator, you get a quotient and you also get a remainder. So the quotient is the equation of your actual asymptote of this function. Well, the remainder doesn't really matter. So your equation is y equals x over 4 plus 1 over 8. And I've actually graphed this for you, and which shows the red as the asymptote function, and the other two asymptotes and their equations that correspond with them are also shown on the left. Thanks for watching and have a great day.